Hello, my name is Kim Holmberg and I'm a researcher at the University of Turku. I'm going to talk today about scholarly communication and scientific misconduct and retracted articles and what kind of impact those may have. Now, scholarly communication is a collection of all those activities, communicative activities that scholars, researchers do. That includes both formally publishing scientific articles and also citing previous work in scientific journals. But also the informal part of discussing research and sharing research outputs on various platforms. Now, the process of conducting research or writing scientific articles, it usually starts with the scholars reading earlier work, getting an idea from what they have read, quite often applying for funding in order to have the means to pursue that idea and conduct the research, collect data, analyze the data, and then write the article. When the article or the manuscript has been written, it is sent to a journal, which sends it forward to peer review. So peer scholars, other scholars read the manuscript and make their recommendation, give their recommendation to the journal whether that article or manuscript should be accepted for publication or not. And then eventually the manuscript, the research will be published and other researchers can read it. Hopefully they will get their own ideas and they will pursue their own research. And so the wheel goes on and on. Now, quite often the manuscript is also sent to a preprint repository at the same time that, usually at the same time that it's been submitted to a journal. So a preprint repository means or is a location, database of manuscripts that have not yet been published. And quite often, and especially during the COVID pandemic, quite often many preprints get or find their way into news media and other platforms. People can read the preprints already and share them on different platforms, and they may have an influence on people's decisions. Now, the danger is that a manuscript, a preprint, might never get published. The peer review process, which is the quality control process of science, may find serious errors in the manuscript, and it may never be published. But because it's already out there, it may have some influence on people's attitudes and opinions. So here we have one example of a preprint from archive preprint repository. Now, this manuscript, this text claims that there's no evidence of the anthropogenic climate change, meaning that there's no evidence that humans are behind climate change, that human actions are causing climate change. Now, we can see that this manuscript, this text, has been discussed in some news platforms, and it has received quite a lot of attention on social media like Twitter, X, and blogs, and some other platforms as well. Now, the thing is that this manuscript was in fact never published. It stayed as a preprint. We don't know the full story behind it. It could be that the author never even tried to publish it, or it can be that it never passed the quality control or peer review process. Either way, the text has not been accepted as part of the scientific knowledge scientific journals are in a way the backbone of science. In their earliest days, in around 1660 and so, and for a long time after that also, the scientific journals, they were the means to disseminate scientific knowledge, but also they functioned as a registry of one's contribution to science. So when an article had been published in Science and the scientist had their name attached to that article, everyone knew that this was that person's contribution to the scientific knowledge. Now there is a challenge in science, and when I talk about science, I mean it as broad a term as possible, including social sciences, humanities, and so on. The thing is that the scientific production increases all the time, rapidly, and that means that no one can follow everything that is published in their own field. And another side of the issue is also that most of scientific journals are in the hands of only a handful of big publishers. Elsevier, Sage, Springer Nature, Taylor Francis, and Wiley, they account for more than 50% of all papers that are being published. When research has been published in a scientific journals, other researchers can read it and they can cite it. They can use that research in their own work and indicate that they have used it through a citation. Now, citations can also be used to discover work of relevance. Eugene Garfield founded basically the citation index back in 1960. Back in that day, the science citation index was a printed volume, well, many volumes of huge books containing citations between research articles. And researchers could use these. They could go through long lists of citations to find relevant work, similar work to their own. Today, all the data is in huge databases like Web of Science, and there are other databases that can be used for that kind of information seeking as well. Now, citations are very important because they are the currency that advances researchers' careers. Merton said that the reference provides a palette of peer recognition, and it does. It's an indication that researchers have used your work. Citations are also used to calculate journal impact factors. The journal impact factor is a yearly average of the number of citations to recent articles published in that journal. This means that the higher journal impact factor a journal has, the more citations the articles published in that journal have received. And that is often taken as an indication that that journal is of greater importance or have a greater impact compared to lower impact journals. Now, this also means that in order for researchers to advance in their careers, they have to publish in high impact journals, because those mean more when they are in your publication list. Citations can also be used to calculate what is known as H-index. The idea behind H-index is that if my H-index is 10, that means that I have 10 articles that have all received at least 10 citations. If my H-index is 100, that means that 100 of my articles have received at least 100 citations each. Now, I may have 300 articles, but only 100 of those have received at least 100 citations. Now, There are several problems with the H index. For instance, more senior researchers kind of automatically have more publications and more citations, because it takes a lot of time to accumulate citations and also to publish articles. So it's H index in that sense can be quite misleading, and it should not perhaps be compared with the researchers or used to evaluate researchers for job applications, for instance. And there's also the question of what counts as authorship of scientific articles. Now, our quite recent physics paper made a new record with 5,154 authors to it. Now, in this article, with it had 33 pages, but only 9 first pages dealt with or described the research. The remaining 24 pages listed the authors and their institutions. Now, the question is how big of a contribution have those 5,000 authors made to that article, but they still get the merit of authorship and all the citations that come to that article. The H5 index is a variation of H index, often used for journals. Basically a variation of journal impact factor, you could say. And the higher the H5 index, or the higher journal impact factor a journal has, the more citations the research articles in that journal have received. And there are, of course, disciplinary differences in how researchers view at these measures, but quite often high-impact journals weigh more, especially in researchers' CVs and publication lists. Now, even though Eugene Garfield came up with the citation index, and which kind of gave the ignition for citation analysis and use of citations as a measure of scientific impact or researchers' impact in some cases, he himself said that citation frequency is a measure of research activity, and that's it. It's not a measure of quality, and not necessarily a measure of impact either. Goodhart's law states that when a measure becomes the target, it ceases to be a good measure. Now, when the target for scientists becomes to get as many citations as possible, it may lead to some questionable actions in order to get as many citations as possible. But citations are important because they are part of the reward system in science. Researchers start their project, they perhaps get money, funding for their research, which helps them hire staff, get the equipment, which helps them get data, and then based on that data and analysis of the data, they can create their arguments and write the articles in order to get even more recognition, which leads to more research funding and more staff and more data, and so on. The circle of the reward system goes on. Now, reliance on these high-impact prestige journals allows these journals to not respond to pressures towards openness. Scientists have to publish in these journals in order to advance in their careers. We have to publish or perish, and this pressure may sometimes lead to scientific misconduct, including fabrication, falsification, and plagiarism even, but also some other adverse side effects, such as self-citations, which means that one tries to increase the number of citations one gets by citing unnecessarily, your own work. Or salami slicing, which means that you may have a good idea, a big idea, and a lot of results from one project, and then you slice those results into as many publications as possible. It can lead to citation cartels. I could, for instance, put a citation to one of my papers in the slides here and ask everyone who's watching to cite my work. That would create a citation cartel. Now, that kind of behavior, scientific misconduct, of course, leads to articles and research work being retracted. Now, what do we mean by a retraction or a retracted article? Scientific articles can't really be removed from the online environment or scientific journals for that matter, nor can they be removed from social media sources where they may have been discussed and shared and forwarded in our social networks. But what can we do then if we can't remove flawed research from circulating networks online? What we can do is we can flag them as flawed, or that there is some mistakes in them, serious mistakes even, and no one should use those articles. So a retracted article, a retraction means that to a certain research article, scientific article, there has been attached a retraction notice, a flag stating that no one should use that article. Now the problem is that the retraction may appear months after the publication or years after the publication. So that flawed research may have had a lot of time to influence people's opinions and research for that matter. Other scientists may have used that research in their own work before the flawed research have been detected, or the reason for the retraction have been detected. Here is an example of a scientific article, looks okay, on the American Journal of Therapeutics. Review of the emerging evidence demonstrating the efficacy of ivermectin, and so on. No notices, no information of possible retraction on this article. And it's open access, anyone can access this, anyone can read it. Now the results in this article state that ivermectin have been discovered in many studies as efficient against COVID-19, which from later research we know that is not true. Now if we search at the same article on PubMed Central, a database collecting medical research, we see that there is an expression of concern that has been published regarding this article. And we also see that at some point this article has been corrected, and there is information about what that correction may have entailed. Now none of this information is available on that the original site where that research is published. Now also we can go to retraction database to search for articles. We can search for articles using the DOI, digital object identifier, a unique identification number that scientific articles all have. Or we can search for articles using the name of the journal or keywords and authors and so on. Now if we search for this article, our example article on retraction database, we find that it has been flagged. There is an expression of concern regarding this article. If we go to Web of Science database, on the other hand, we find a retraction notice for this article. In this database, the Web of Science citation database, this article has been flagged as retracted and no one should use it in their work. Now, we have 4 different platforms, 4 different sites giving a bit different information regarding this article. So anyone can imagine that it's very difficult to really understand what is going on with this article. What source, what information should one trust? Now in this case, the only choice is to find other sources, read how this article has been treated in other research maybe, and also find other research on this drug, namely ivermectin. What has other research found out about this case? Now the problem is that even if this article has been retracted, or if it has a raised concern, there is obviously something fishy going on with the article. Now, from this citation database, we see that this article has received 73 citations. That means that 73 other research articles are citing this research article. Now, from that number, we don't know whether those articles are citing this article in a positive note or a negative tone. We don't know if they are criticizing the findings or if they use the findings to support their own claims. This article has also received a lot of attention online on different platforms, such as social media platforms, Facebook, Twitter, X, and so on. Over 36,000 mentions on Blue Sky and X and Facebook and other social media platforms. Almost 200 mentions in news and blogs and podcasts, and it's quite a lot of attention towards a specific research article. If we look a bit closer at that attention, we see, for instance, on X, here's a screen capture of the top accounts on X that have shared this article. And we see that the top account have actually shared this article 603 times on X. Now the question is, why? Why have they shared this article so many times? We can only guess at that before taking a closer look at the context in which those articles have been, or this article have been mentioned by this user. My guess is that this is a bot account automatically sharing this article and similar content, probably. Most likely disinformation about this particular drug as a cure for COVID. Here's a screenshot of a very recent entry on X. And if we look at the text here, we see that it begins. The message begins with the title of this article, followed by the author's comments. Proves is effective, works, safe, and inexpensive. The media, government lied. And this is just in October 25 that someone has posted this, indicating or using this research as a well, we could even say that using this as a support of conspiracy theories, stating, the author here is stating that the media and governments have lied, and this article proves that. Now, as I said, this particular case, it's not a clear-cut case, and it can sometimes be very difficult to see whether a research is problematic, whether that science is unreliable. But by using different angles, different sources, one can triangulate other opinions, other results that either support the findings or that condemn the findings of problematic research and unreliable science.